Hi, my name is Alan Shaw. I'm in the Department of Neuroscience. I'm a first year PhD student, and my research interest is the development of amyotrophic lateral sclerosis and frontotemporal dementia, specifically the role of astrocytes in this. Today, I'm here on behalf of the organizing committee for the departmental research meeting to interview Joshua Astley. And how are you doing today?
I'm good, thank you. Yeah, my name's Joshua Astley, and I'm a second year PhD candidate in the Department of Oncology and Metabolism. My research largely focuses on the use of deep learning in functional and structural lung imaging. So I do a lot of work kind of on the computer science side and applying that in various ways to lung imaging processes.
Okay, so what did you present at this year's meeting? You just branched a bit on that.
Yeah, cool. So at this year's meeting, I gave an oral presentation detailing the performance of an artificial intelligence algorithm that is capable of delineating the ventilated or other functional part of a hyperpolarized gas MRI scan. So this is a process called segmentation, where you classify parts of the image as being ventilated parts of the lung. And we develop an automated algorithm to do this that is performing better than conventional methods at this point.
That's really interesting. So what were the key findings of this talk?
Yeah, so we kind of compared what we're doing against kind of previous approaches. So in the general category of artificial intelligence, you have machine learning approaches, which we've been using previously. But we employ these kind of like deep learning approaches that generate a model that's capable of accurately segmenting ventilated regions of the lungs from hyperpolarized gas MRI scans. And we acquire these images using multiple noble gases in a large and diverse data set of patients with a wide range of diseases. So we show that the algorithm is capable of delineating segmentations regardless of which noble gas was used or which disease is present in the patient. And then we demonstrated that this model significantly outperforms the conventional methods used in our group for hyperpolarized gas segmentation.
That's really interesting. So what are the implications of this?
So this work has been published at a couple of different conferences and stuff. But that's kind of not the part that I think is most interesting. I think the part that's most interesting is how we're now using it in our clinical service. So the hyperpolarized gas segmentation stuff is now being used in several clinical research studies. And it's also being used clinically at the Sheffield teaching hospitals for patients who are referred with respiratory diseases for clinical hyperpolarized gas scans. So this allows people like me who edit the segmentations to perform these segmentation tasks in a significantly shorter time and hence provide clinically relevant biomarkers faster to the patients and ultimately benefit patient outcomes, hopefully.
And is that just in Sheffield at the moment, or is there the idea to expand that across the NHS?
It's just in Sheffield at the moment. I think before it can be expanded across some kind of across multiple institutions, you need to publish research showing that the model is robust in kind of external validation cohorts. And I think we're working on that. Hyperpolarized gas MRI is a pretty new modality, and the Polaris Lung Imaging Centre at the University of Sheffield is the only place in the UK where you can clinically get a hyperpolarized gas scan.
Okay. Yeah.
Not in a research study. So the data set kind of across the UK isn't that large. There's some centers in the US that also have approval, I believe, and they have some scans as well, or the scans from research studies, but it's kind of hard to get multi-institution studies like that. So yes. In the UK, it's mainly focused in Sheffield right now.
Okay. So what's next in your research? I know you mentioned in your talk about having a first author paper from this, but obviously you're a second year PhD student. So what's the goal for the rest of your PhD and beyond?
Yeah, so kind of I think it was last October we got a first author paper out in the MICI conference, which is kind of a long paper and it's peer reviewed and stuff. And since that time, we've built upon the work. We've done extensive parameterization and more robust validation to kind of decide which architecture we should be using and which loss function we should be using. And we've managed to get improved results since that previous work. So we're working on a full length paper at the moment Hopefully submit that to a high impact journal in the next few weeks. That's the plan at the moment. And then,
Fantastic.
yeah, I don't know if there's like, I mean, this is related to the project that I presented in the abstract. There's other work going on and stuff as well. But for this work, hopefully we've built on it enough that because of the parameterization, we can now sort of show why we're doing what we're doing, what decisions we're making with the neural network, why we're training it for the length of time we are, why we're using the loss function, and we can show that the ones that we're using are significantly outperforming other ones and things like that.
Great. And have you got any plans for you personally in research?
Yeah, so I've still got a year and a half to go. So at the moment, I'm just trying to continue working hard, hopefully publish a few more papers, can try working hard and all things go well and things like that. I'm still deciding whether I want to stay in academia or transition to industry. But I think regardless of like which option I choose, I want to stay in research. And I think I like doing work that's like I find meaningful. And I think doing this kind of stuff in the medical imaging field, focusing on deep learning, I find pretty meaningful on a day-to-day basis. So I'm just going to continue doing this for now and see where it takes me.
Well, it's good. It's taken you very well so far. I'll just go off script a little bit at the end. How did you have any interruptions last year, and how did you get through this? Do you have any messages for others that might be in a similar situation at the moment?
Yeah, I can't really speak to many challenges because I was super fortunate. The role that I have as an imaging scientist and as a computer scientist is largely decoupled from being in a specific position. So most of my work transitioned very, very well to working from home. And in fact, at points when, there's not much to do, it can be like you can be working quite a lot, but it's hard to, when you're working from home, you have to strike a balance of like separating like your working space from your like living space and stuff. So I think that's pretty important to keep like long-term motivation, long-term productivity going, rather than just in short bursts kind of getting burnt out and things. But I was really lucky that my work wasn't too affected by COVID in terms of my day-to-day tasks and how I could complete my research. So yeah, I think that helped with being able to develop this work kind of quite quickly within kind of the first year and a half of my PhD. I didn't have that many distractions at home and things. Kind of
fantastic. And then finally,
I'm excited to go back to the office. At least.
Yeah.
I don't want to do it though if it's like you have to sit at my desk and wear a mask the whole time, or like there's super loads of rules. Like I'd rather be at home where I can just chill more rather than be in that situation. I'd like to be in the office and it be chill, but if that's not possible, then
I've really enjoyed the kind of blend of working from home and parts in the lab. And I hope to an extent it goes on even for kind of PhD students. I think the flexibility allows you. Obviously, it works for some, doesn't work for others, but I've found it quite useful.
I think a lot of people proved this year as well that like they can work from home and be just as productive. Like, so then afterwards to say to people, no, you need to come into the office to be productive, kind of doesn't make sense anymore when people have been productive for a whole year and been churning out their work from in these like kind of crazy circumstances. If they can do it, then they can do it from home normally.
And so what do you see, what do you envision for deep learning in kind of the health space going forward, maybe 5-10 years in the future? Will it be ingrained into everything we do, or?
Yeah, I think it's just going to happen more and more in the background without the kind of end user really even seeing what's going on. Like I think you're going to be, as an end user, as a clinician or something, you're going to be met with various predictions from some software, and really kind of what's happening in the background in terms of the deep learning predictions are kind of going to be kept away from you a little bit. But I think to get to that point, to get to like trust in that kind of medical system, I think we need a bigger focus on explainable deep learning. That's a little bit easier when it's not imaging. So if you're looking at sets of like data of like age and characteristics and things like that, it's a little bit easier to get kind of which features are being mapped. But in imaging, that's quite difficult. So I think that's going to be a challenge in the next 20 years to kind of get some way of finding out, explaining to people why decisions are being made for them to fully trust the integration. But I think if that can be done, then the integration will be pretty swift after that.
Yeah, we certainly have collaborations that are more looking at the machine learning aspect, like drug discovery, and that's been fascinating following. But yeah, I agree with you. You can kind of almost follow the rationale a little bit more, whereas some of the really deep learning seems.
Yeah, and in imaging as well, you're obviously kind of working in 3 dimensions. A lot of the features, the network is kind of like you're looking at like 6-dimensional kind of like layers and things, and any kind of representation in that layer just isn't going to make sense to.
Right. Yes.
Like you can't draw it out physically what what kind of features it's looking for. It seems to be like pretty abstract at that point, but there are people working on things all the time, and I'm always amazed by like how quickly things turn around where like some new discovery happens. Like AlexNet, which is a deep learning paper, was 2012, and since 2012, I mean, now everyone has deep learning pretty much on every app that they go on, every app.
Yeah, that's scary. Yeah.
Like all the health apps, like if you relating to medical imaging, that kind of stuff, like they're using deep learning in the background to predict certain things, predict trends and things like that. It can't directly measure a lot of, like your Apple Watch can't directly measure your VO2 max, but it gives you a VO2 max measure. And that's
I've always wondered what my watch. Yeah, okay.
When the VO2 max measure is validated is through an algorithm. The algorithm is accurately kind of like predicting what it will be, but it can't directly measure it. And I think we're going to see things like that more and more in kind of wearable devices, especially in the health space.
Okay, well, thank you very much for attending this. It's been really interesting chatting with you, and I look forward to following your work in the future.
Yeah, that's cool. Thank you, man. It was really good chatting.
Thanks a lot. Have a nice afternoon.
Yeah, you too, mate.
Yes.